Welcome to SRA 221. In this video, we will be discussing authentication. The first thing that we will look at in this lecture is what authentication is defined as. Then we will discuss the various types of authentication, including message origin and message content authentication. We will then discuss the basic steps for authentication and possible attacks along with methods for overcoming some of the most common attacks authentication mechanisms are subjected to. Finally, we will learn throughout this module the distinction between one-way authentication and two-way authentication. In general, authentication is a process to confirm the identity of a user requesting a service or a message sender, and also confirms the integrity of the specific information. Authentication is very common in the real world. For example, you need a photo ID to go on an airplane. A more complicated example is online banking. Suppose you need to transfer a certain amount of money from one account to another on the internet. You need to first prove your identity before you're allowed to transfer your money, and then the authentication will be confirmed to be truly from you, and thus you cannot repeat the transaction later. In the cyber world, authentication is done by computers or computer programs. Now we will take a look at digital identity. The most basic forms of digital identity include login name and password. But now, with new opportunities and services available on the internet, the notion of digital identity is greatly evolved. Identity is intended as a set of attributes that allows you to uniquely be recognized as the client of your own identity. Another important concept is message origin authentication and message content authentication. Message authentication provides two services: message origin authentication and message content authentication. Message authentication verifies that the receiving message comes from the alleged sender and that the message origin authentication remains the same. Additionally, it provides integrity assurance that the message is not tampered with and the original message remains in place during transfer. So you may be wondering, how can I actually prove my identity? Authentication is usually based on the following three factors. 1. Who you are. For example, fingerprint, face, voice. 2. What you know. For example, your mother's maiden name, your birthday. 3. And what you own. For example, a smart card. Sometimes a combination of different factors is used. For example, an ATM card and the PIN are used together to verify your identity and access your bank account information. This is referred to as two-factor authentication method. An authentication method that you are usually exposed to is one-way authentication. With one-way authentication, you only need one method to identify yourself. Logging into your courses, you enter your username and password that you are using. For example, your browser sends data to the server, and the server compares the credentials with the stored information. If the match is successful, then there's a successful authentication. Otherwise, there is no successful authentication, and the authentication fails. Here you will see an example of what we just discussed. As you can see here, we have the user who is browsing the web. She goes to the eBay website to log on to her account. She enters her password along with the user ID. Now on the server side, once it receives the username and password and matches it with the information stored in its database, if there is a match between what the client sent and what is stored in the database, it will allow the user into the system. This method of authentication has two big security flaws. The first flaw is that the information sent by the user provides no protection, which represents a serious security problem because an attacker may be able to intercept this information. The second flaw is that the password in the database is not hashed, creating an additional security problem. The security flaws can be mitigated. Regarding insecure transmission, an encryption of the password is needed. There are many cryptographic protocols and algorithms out there, and we need to think about which one would be sufficient and most effective, whether it is symmetric encryption or asymmetric encryption. The second idea to reduce the security vulnerability is creating a one-time password. With one-time password, what happens is that every time the user authenticates, the user will use a different password and will still be able to recognize that all of these one-time passwords are generated from the same user. To address the second security flaw, passwords stored in a database or password file should be hashed. What this function does is it takes the clear text password and converts it into a hashed function password that only the server and database can comprehend. If an attacker were to get a hold of the database or password file, they would not know the actual password of the user. If an attacker were to get a hold of the database or password file, they would not know the actual password of the user. So you may be wondering what hashing is. Hashing is a one-way function that allows the user to go from input, x, to an output, f(x). The important part of this is that it is only a one-way function process, just like a juice maker. If you give a juice maker an orange, you get juice, but you cannot go back from juice to a full orange. This process gives a solid guarantee to our password file, because if an attacker were to get a hold of it, they would not know what the hashes mean. Here you will see an example of hashes. You can also see what the input is along with the hash function that will be stored on the server. You will notice that no matter how long the input is, the output hash function is always the same length. So if you have a password that is only 3 characters long, it will still be the same hashed function length of a password that contains 5 words. In summary, hashing passwords provides the following benefits. 1. It is easy to compute the hash value for any given message. 2. It is infeasible to find a message that has a given hash. 3. It is infeasible to modify a message without hash being changed. 4. It is infeasible to find 2 different messages with the same hash.